Hi student, welcome back to computer graphics subject, and for today's topic is on the topic of illumination and lighting. Here is the topic that we're gonna cover in this chapter, and at the end of the chapter I hope that you'll be able to understand what is illumination, the type of illumination, shadings, shading models, lighting, light source, light and materials. Before we go into the deepers on the illumination and lightings, let's familiar with the term that we have to go throughout this chapter. First is the illumination. Okay, so what is illumination? Basically, illumination is a transport of energy. In particular, is the luminous flux of visible light from the light source to any surface or any point in the computer graphics. Okay, so this is illumination. It's nothing, it's just a transport of energy or the transport of visible light from any light source to any kind of surface and point on the object. So this is illumination. So what is lighting? Okay, lighting is the process of computing the luminous intensity. For example, outgoing light is a lighting that used in the scene, okay, at a particular 3D point, usually on a surface. Okay, so lighting is nothing, it's just a process of computing the luminous intensity or outgoing light at the surface of the 3D object or any graphic on the computer graphics. And what is shading? Okay, shading is nothing, it's just the process of assigning colors to pixel. Alright, so this is shading. We assign the colors to the pixel of the object in computer graphics. One of the main goal of having lighting in the scene is because we're gonna have a realistic 3D graphics. Okay, if your scene is just a scene without lighting, your scene will be dull and boring. So one of the main goal for having lighting is to have a realistic 3D graphics. And basically lighting calculation is disabled by OpenGL. Okay, by default the OpenGL will disable the lighting calculation. So when you see the colors in your object in the OpenGL is basically because it's used the current value as set by the function of GL color. Okay, so in order to enable the OpenGL for a lighting calculation, we need to enable the lighting by calling GL enable GL lighting. Okay, so this is the command that we need to use in OpenGL in order to enable the lighting. Okay, so if that all you do, you will find that your object are completely black. Okay, if you want to see them, you have to turn on some light. Okay, so here are the example of the scene. By having the lighting in the scene will makes your scene look more realistic. Why do we need lighting and shading in computer graphics? Can you see at this example here, I have two figures here. Okay, the first sphere and the second sphere. Okay, what is the differences between these two spheres is that this sphere is without applying the lighting and shading, while this sphere is the sphere with shading. Okay, you will see that the sphere without lighting and shading is just a plain sphere. Okay, we want a sphere with shading because the sphere with shading or the object that applying the shading, it will have a visual cue for a humans. Okay, and this visual cues will add more dimension to our object. Okay, so we add more dimension at shape, light position, viewer position, surface orientation, material properties, and etc. So this is other component that play an important roles for the shading. What causes shading? Okay, how the shading happens. So basically shading caused by different angles with light, camera at different points. Okay, so this is how shading happen. Okay, is caused by the different angle by the light and also by the camera at different points. Okay, for example here is the figure of the human. Okay, let's say our eye is here and this is the object and also this is the lighting. Right, so in order for shading to be happens is caused by the different angle with the light. Okay, so the light is coming from here. Okay, so it's caused the reflection to different point. How about illumination? Okay, when it's come to the illumination, is nothing is basically refer to the light or lighting. So illumination is nothing is the interaction between the light and the surface point to determine the final color and the brightness of the object. Okay, so this is about illumination, is the model of the interaction between the light and the surface point to determine the final color and also the brightness of the object in computer graphics. And basically OpenGL will compute the illumination at the vertex level. Okay, for example, here this is the light and this is the vertex of the object. Okay, and then the light will strike to this object and it will cause the illumination to happen. Okay, it's caused the light. For shading is nothing is just the process of applying the lighting model at a set of points across the entire face, or indirectly says the shading is the process of assigning colors to the pixels. Okay, let's say we have the lights here. Okay, and this is the object and this is the pixel. So basically this process of assigning the colors to each pixel is called as a shading. Generally there are three types of shading models or the type of shading, which is flat shading, Gouraud shading and Phong shading. So let's find out what is the differences between flat shading, Gouraud shading and Phong shading. If you look at the three figures here, I think you can guess what is the differences between these three kind of shadings. Here is the features of flat shading. Okay, so basically this flat shading is the lighting is considered as per polygon and basically was used for high speed rendering, and all of the vertex of one polygon have the same color. Okay, so all of these vertex, okay, in this surface have the same color for all. Alright, and its difference between polygon, each polygon have different kind of flat shading and is not a smooth transition for this kind of shading. And here is the Gouraud shading features. The light of shading for Gouraud shading is considered as per vertex, and this kind of shading with interpolative shading, and it will calculate polygon per vertex color and the interpolation of the colors for interior points. Okay, you will see that this Gouraud shading have a smooth surface a bit compared to the flat shadings. This is the features for the Phong shading. Okay, not to be confused with the Phong illumination. So Phong shading is not a Phong illumination, it's different stuff and different concept. Okay, and basically this Phong shading is will spike the light per fragment. Okay, per fragment, and it will interpolate the surface normal instead of the intensity values. Okay, is more toward the surface instead of the intensity, and it will do the calculation of the intensity using the interpolated normal, and it will give a better result, especially for the highlight. There are three attributes or three components of the illumination models. Okay, basically an illumination model usually consider first is the light attribute. Alright, so this is the first component, light attributes. For example of the light attribute is in terms of the intensity, the color, the positions, the direction and the shape. Alright, so here are the first component on the light attribute. Beside that, an illumination model also contain of the take into account of the surface attribute. Okay, first we have light attribute, next is the surface attribute. And the example of the surface attribute such as color, reflection, transparency and etc. Okay, light attribute, we have light attribute, surface attribute, And the third component of the illumination model is in terms of the interaction. Okay, and what are the interaction? For this illumination model is the interaction between the light and also the object. Alright, so here are the component of this illumination. Okay, light attribute. Here we have the light attribute of the surface attribute. Okay, on the surface attribute, and also the interaction between the light itself and also this object. Illumination model can be divided into two types. First is local illumination, and the second type is the global illumination. So let's find out what is local illumination first. So basically, local illumination is the type of illumination that does not track the interreflection. It's only one bounce. Okay, it's only one bounce, and is not gonna reflect to other surfaces. Okay, and this local illumination is only considered the light. Okay, is only considered the light and the observer position. Okay, for example, if the observer or the eye is here, and the object material properties. Okay, so these are only three components or three things that this local illumination consider. First, the light. Okay, the observer position, and the object material properties. Okay, for example, this is the surface or the material properties. So the light coming from here, okay, and then it's bound to here, and then it's only bounds to only one reflection. Okay, it does not track interreflection. This is the local illumination. How about global illumination? For global illumination, it will take into account the interaction of the light from all the surface in the scene. Okay, so this is the differences between the local illumination. For global, it will take all the interaction of the light from all the surface in the scene. Let's look into this figure. We have object 1, object 2, object 3, and object 4. And for this kind of global illumination, it support the interreflection. Okay, for example, we have the light, and this light is spiked into object 1, and from object 1 surface here, it will reflect the light to object 2, object 3, and from object 2 will reflect to object 4, object 4 will reflect to others, and object 1 also will reflect to its own surface, and this surface for object 2 also will reflect to object 1. So it supports the interreflection for global illumination. Light and materials. When a light strikes a surface, some of it will be reflected. Exactly how it reflects depends in a complicated way on the nature of the surface itself, or in another term for the surface is the material properties of the surface. Okay, so basically when the light come in, okay, some will be reflected, some will be absorbed. So this reflection is basically solely depend on the surface or material properties of the surface. In OpenGL, the complexity is approximately by two general type of reflection. Okay, so in computer graphic or in OpenGL, there are two type of reflection. One is specular reflection, and the other one is diffuse reflection. So let's find out what is specular reflection and what is diffuse reflection, and what is the differences between these two types of reflection. What is specular reflection? When there is an incoming ray of light is reflected from the surface intact, and this reflected ray make the same angle with the surface as the incoming ray. Alright, and a viewer can see the reflected ray only if the viewer is in exactly the right position only. Alright, where this right position is referred to somewhere along the path of the reflected ray. Even if there is an entire surface is illuminated by the light source, the viewer will only see the reflection of the light source as those point on the surface only, where the geometry is right. Okay, let's look into this figure to sum up what is described up here. Okay, when there is an incoming ray of light, you will see here there is a ray number 1, ray 2, ray 3, ray 4, ray 5, ray 6 here. Okay, so when there is a ray of light is reflected, okay, it's go to this surface. Okay, this is the surface or the material properties, and there is a ray of light coming from here. Okay, when it's bound into this surface, it will reflected from this surface, and this reflected ray make the same angle. Okay, this ray, okay, this ray of light make an angle and then reflect to this ray make a reflect to this ray will make the reflect to this, and so on. Okay, and the viewer will only see this reflected only if the viewer is in exactly the right position. Okay, for example, if the viewer is here, so this viewer will only see this ray of light only. Okay, it's only managed to see this ray of light only because it's in the right position of this ray, okay, of this reflected ray. So this is the specular reflection. How about diffuse reflection? Basically, for diffuse type of reflection is when there is an incoming ray of light, the ray of light will scatter in all direction equally. Alright, all of this direction for the reflected light is scattered equally. A viewer would see reflected light from all points on the surface, and if there is an incoming light arrive in the parallel rays that evenly illuminate the surface, then the surface would appear to the viewer to be evenly illuminated as well. Okay, you can look into this figure. When there is an incoming ray of light here, okay, this ray coming here into the surface. Okay, this ray number 2, ray 3, and ray 4. Okay, incoming ray of light intact into this surface, and there is a reflection happen. Okay, the light from all point on the surface reach the viewer through here, and then you will see that all of this incoming ray is scattered. Okay, is scattered in all direction to here, 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 and here. Is reflect to here, this angle, this angle, this here, reflect this angle, this area is reflects in all direction equally. Okay, so that's why the viewer can see this incoming ray or this reflected light in all the point on the surface. Alright, so this is the diffuse reflection. Generally, there are 3 types of basic light source. Okay, there are 3 basic light source in computer graphic. First is the point light, second is the directional light, and the third one is the spotlight. Okay, so what is the spotlight? What is the point light? What is the directional light? And what is the spotlight? So let's find out in the next slide. But basically, the light intensity of this basic light source can be independent or dependent of the distance between object and also the light source. Okay, so let's find out how the point light looks like, how the directional light works, and how the spotlight working. So what is directional light? Directional light is produced by a light source that an infinite distance from the scene. All of the light ray emanating from the light strike the polygon in the scene from a single parallel direction and with equal intensity everywhere. Okay, and the sunlight is for all intents and purpose a directional light and is characterized by the color, intensity, and also direction. Okay, based on the name itself, directional light is a light source that coming from an infinite distance, and all the light ray is strike to the polygons into the scene from a single parallel direction and equal intensity everywhere. Okay, so based on the direction, okay, the ray is coming from the directional light. And this is the example of the 3D object, okay, that have a directional light from the front of this hole. Okay, this hole is an object here, and then the directional light is coming in front, okay, from the front. It's direct from the front, so you have this kind of lighting for this hole. Okay, directional light is based on the direction. What is point light? Point light is basically a light that gives off equal amounts of light in all directions. The polygons and the part of the polygon which are closer to the light appear brighter than those that are further away from the point light. And the intensity of the light source hitting the object is a function of the distance between them. And a bare bulb hanging from a cord is essentially a function like a point light. And basically this point light is characterized by color, intensity, location, and the fall off functions. Okay, if you can look into this figure, okay, down here this arrow is representing the ray of this point light. Okay, you will see that this point light is give off equal amount in all direction. Okay, this is the point light working. How the point light working? It will give off equal amounts and in all direction. And here is the example of this old 3D object, and then they have put the point light slightly in front of this old. Okay, so you will see this effect of having point light, and point light will give all equals of amount of light in all directions. So this is the effect of point light. How about spotlight? Okay, spotlight is the light that radiates light in a cone, with more light in the center of the cone and gradually tapering off toward the side of the cones. Okay, think of something like a flashlight or a car headlight as opposed to a bare bulb hanging on a wire. More advanced spotlights have a fall-off function, making the light more intense at the center of the cone and softer at the edges, and is characterized as a point light, an axis of directions, a radius about that axis, and possibly a radial fall-off function. Okay, so basically this spotlight is radiate the light in a cone shape. Okay, it look like a cone shape here. Okay, it start from this point and then this ray is coming out like a cone shape here. It will give you a spotlight or make the object as a center of the attention. It's used to highlight the object. Okay, look into this figure. Okay, this owl is a 3D object, and they use the spotlights in front of the owl aim at this owl. Okay, make this owl as the center of the attention. It's gonna highlight only this object, so it's put this spotlight like a cone shape, so it's directly to this owl or this object in the computer graphic only. That's all for today's topic. So what we have learned in this topic is we learn on the lighting, on the illumination, and on the shadings. And we also learn about the type of illumination consists of global versus local illumination, the type of shading, flat shading, Gouraud shading, and Phong shading, the light source. Okay, we have point light, spotlight, and directional light. Alright, so thank you and have a nice day. See you in the next video.